All right. In this video, we are talking about graphs of all the other trig functions like tangent, cotangent, cosecant, secant. So again, to kind of like have a good understanding of how things are going to go today, I would highly recommend at least watching the previous video that deals with sine and cosine, because I'm going to use a lot of the things I talked about in there. In this video to kind of make sense. So with that, let's kind of go ahead and get started. So again, like last video, we created our sine and cosine graph using a table because tables help us make graphs, and we're going to use a unit circle to kind of fill in our table. So let's get that done first. So over here, I'm going to kind of like take my x values and put in all the angles for different sections of it. So I know there's 0. Well, when tangent, remember, is always y over x sine over cosine. So when it's 0, that's really just saying 0 over 1. Well, that's 0. So then we get pi over 6. Well, pi over 6 is 1 half over root 3 over 2, which is the same thing as multiplying it by 2 over root 3, which is 1 over root 3 about 0.6. All right, so then I keep going to pi over 4. Well, pi over 4 is root 2 over 2 divided by root 2 over 2, which is the same thing as 2 over root 2, which is 1. And then pi over 3, which is going to be, what do we got over here? That is going to be pi over 3 root 3 over 2 times 2 over 1, which is what that 1.7, roughly 1.7. So again, these are crazy numbers. I don't want to deal with crazy numbers. What is this? So the goal again is like we did in the last videos, like identify points that we like. All right, so what's next? So let's just actually talk about one more point that doesn't fall in the first quadrant, right? It's just on the axis. What about the point pi over 2? What about the point pi over 2? What happens when we have this? Well, that's saying this is 1 over 0. 1 over 0. Well, that can't happen. So this is actually undefined. That is undefined. Right, so with that, rest kind of like falls into place. So let's do, well, 2 pi over 3, 2 pi over 3. Well, again, anything to do with the denominator 3 is going to give me some sort of a weird number I just don't want. The ones that I do want are going to be like this zeros, this pi over 4, and then something to do with like easy things that I can do. Right? So 2 pi over 3, not interested. What I'm really interested in is 3 pi over 4, which is going to be, again, y divided by x. So in this case, this is going to be root 2 over 2 times negative 2 over root 2, which is negative 1. And then, again, pi really doesn't fall in a quadrant, but, it gives me a pretty good number that I do like, which is going to be 0 divided by negative 1, which is just 0. So again, I got 2 good points right over here to work with. And then let's keep going to our third quadrant. Again, 7 pi over 6, not interested. 4 pi over 3, not interested. So like 7 pi over 6, I don't care. What I do care about is this point, 5 pi over 4. 5 pi over 4 is going to give me positive 1 because I'm dividing a negative by a negative in that third quadrant. And again, this 4 pi over 3, I'm definitely not interested. Again, it doesn't fall in the third quadrant, but I am interested in 3 pi over 2. Well, 3 pi over 2 is negative 1 over 0, which again is undefined. Undefined. So again, 2 good things that came out of this area. All right, so let's wrap this up over here. So we are going to see in our fourth quadrant. So fourth quadrant is going to be our 5 pi over 3. Don't care. Some decimal number, I don't care. But I do care about this 7 pi over 4, which is going to be negative 1. Don't care about 11 pi over 6. And I do care about 2 pi because 2 pi is just going to be 0 over 1, which is 0. And then from there, we will take a look at these two numbers and go from there. So let's make this into a little graph. And let's see, undefined. So what happens when something is undefined? So undefined really just means it can't exist there, right? So undefined is kind of like this asymptotes for us. So let's plug those in here. So this is an asymptote right over here. There's another one at 3 pi over 2 over here. Well, with that, I can kind of see, if there's an asymptote at pi over 2, clearly it's going to have one at negative pi over 2. That means there's also going to be one at negative 3 pi over 2. Okay, so now let's start graphing. So over here, I have 0, 0, I have 0, 0. And then I have pi over 4 is 1. So pi over 4 is 1. So let me label these properly just so they make sense. So let's just label this 1. Let's label this negative 1 is 1. Right? And then, well, if I think about it this way, if pi over 4 is 1, and if I do a negative rotation of it, right? If I go negative rotation, that means I'm sitting in the fourth quadrant where I have a positive and a negative. So that's clearly going to give me a negative number. Right? So then our graph actually kind of looks like this, right? This graph is going to try to approach the asymptote, but never, ever, ever kind of cross it. Same thing over here. So there it is. There is our graph of tangent of x. And you're like, wait a second, I don't get it. Where did you get this negative pi over 4 thing from? Well, let's ignore it for right now. And if I ignore it, I know at pi, this is at 0. And then I know at 3 pi over 4, it is at negative 1. I calculated that out. I literally did it when we were doing the table, right? It's coming from here and here. Well, then 5 pi over 4, well, I saw that's right there at 1. So again, this leads me into this idea of getting that graph. So you can kind of see, there it is. There's that same exact graph all over again. 7 pi over 4 was sitting at negative 1. This is at 2, so I clearly know that this is going to continue the same little pattern. So if I were to do this, I can do this over here, 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 and I'm going to get the graph that I want. So there it is. There we go. There we have our graph of tangent of x. So like we did in the last video, let's try to kind of come up with these key characteristics of our functions for tangent of x. So tangent of x, what am I seeing? So y is equal to tangent of x. Okay, so let's see here. So let's start with our domain. Well, can this exist at every single place? Well, no, because we have things that are undefined, right? So we can definitely say this is going to be all real numbers except. So now where does it not exist? Well, it doesn't exist at pi over 2. It doesn't exist at 3 pi over 2. And so on and so on and so on. So we can say that this is all real numbers except odd multiples of pi over 2. Odd multiples of pi over 2, right? 1 pi over 2. 3 pi over 2, and so on and so on and so on. You can, the next one will be like this. 5 pi over 2 would be the next one where it can't exist, right? So if I were to just kind of stretch this out over here, so this is going to be 4 pi over 8 pi over 2, which is 4 pi over 2. What am I thinking? 4 pi over 2, and then this is going to be 5 pi over 2 right over here. 5 pi over 2. And wait, something isn't right. I can't, clearly my brain is not functioning right now. So this is 7 pi over 4, 8 pi over 4, 9 pi over 4, and then comes 10 pi over 4, which is 5 pi over 2. I was like, why is this not working? Because clearly this is where, my asymptote needed to be. right over here. And then if I were to finish graphing this would go like right over here. Right. So odd multiples, just know that domain is all real numbers except for odd multiples of pi over 2. Range, well, range is just negative infinity to infinity. And then we can say there's definitely vertical asymptotes, and vertical asymptotes occur only at odd multiples of pi over 2. And y-intercept is at that 0, 0. So y-intercept is at 0, 0. And let's take a look at some key things now. Like we were kind of like observing some key things about points. So like something to do with this, this, and this, right? And before we do that, let's write down our period. Well, over here, how often does it repeat itself? Well, I can see from here is half a pi. Here is half a pi. So period really is pi for tangent. It's pi. Period is pi. Okay, so now let's actually talk about some of these key points. Let's first talk about the x-intercept. Where exactly do we see the x-intercept in that period of pi? Where exactly does it show up? Well, it shows up if you kind of like really take a look at it. Here is the period, right? It really shows up halfway between our two vertical asymptotes. So x-intercept always is halfway between the vertical asymptotes. It's always halfway. Like if you see it over here, if you take a look at this period, you can clearly see it is halfway. And then what is happening? What is happening over here? So if this is halfway, this is halfway. Well, this is 1/4 of the way. This is 3/4 of the way. What's happening? 1/4 and 3/4 of the way. Well, 1/4 and 3/4 between are vertical asymptotes. What do we see? Well, we see there is this y coordinate. There is this y coordinate between the vertical asymptotes. The y coordinate is -1 and 1. So 1/4 is always -1. 3/4 of the way, it is always +1. So that's going to be super duper crucial in making our life easy in graphing tangent functions. So there it is. Those are the key characteristics of it. So 1/4 of the way, halfway, and 3/4 of the way. 1/4 is -1, halfway is the x-intercept, 3/4 is your +1 y value. All right, so let's take a look at some examples. Let's put all of that into practice. So here we go. Example for this is asking us to graph y is equal to 2 tangent of x over 2, and it's actually giving us a specific period to graph it into. So we need to be able to show the tangent graph from the periods negative multiple periods ranging from negative pi to 3 pi, all the graph in there. All right, so let's see here. Just like we did in the last example, we're going to start with finding our asymptotes. We're going to talk about the period, the x-intercepts, the y-intercepts. So let's start with the period first. Period, in this case, is not going to be 2 pi divided by b. It is not going to be 2 pi divided by p. It's actually going to be pi divided by b, because remember, tangent repeats itself every pi period. Right? So that's going to be pi over 1/2. Well, that's the same thing as 2 pi. 2 pi. Okay. So then how do I find out where these vertical asymptotes are going to be? I know what the period is going to be, but how do I find out where the vertical asymptotes are going to be? To find out vertical asymptotes, what we do is finding our asymptotes. So what we do is we take this x over 2. We take this, whoops, not equal to, sorry. And then we set it, the inequality to the original period. So original period is pi over 2, negative pi over 2. Well, I can kind of see that, like it's coming from right over here. Negative pi over 2 to pi over 2. Now, could I have done positive pi over 2 to 3 pi over 2? Sure, you can. Like, it's the same period. As long as you just kind of take the whole period and like those angle values, you can solve this. So, but it's just negative pi over 2 and pi over 2 just kind of like are the easier-ish ones to work with, right? So in order to solve this, I'm just multiplying both sides by 2 because of this to solve for x. Right? So here we go. So x, and then if I multiply by 2, I can see that my asymptotes are going to be between negative pi and pi, at least for one period. At least for one period. That's just for one period. Okay. So then I'm going to go ahead and plot them over here. So let's see, this is, let's just say this is pi over 2. So this is pi, negative pi over 2, pi, negative pi. Right? So that's at least where the first period is going to be. And it kind of makes sense, right? It better be from negative pi to pi because my period right here shows 2 pi. All right. So we have that done. So now our x-intercept, I don't see anything moving up and down, right? I don't see a graph being shifted up and down. So x-intercept. Well, we know the x-intercept is just halfway. X-intercept is halfway between vertical asymptotes. So we know our x-intercept is right over here. This is the halfway point. This is the halfway point. And then our y-coordinates. Well, y-coordinates. Well, we know the y-coordinates are usually -1 and 1. So -1 and 1. But except there is a vertical stretch happening because of that too. Like it's not like an amplitude anymore. So don't call it an amplitude. It's just a regular vertical, stretch happening to the graph. And really what we're doing is we're just going to multiply 1 and -1 by whatever the value is right over here. So this becomes 2 and -2 because we're multiplying it by that. Right? So then we can say 1/4 of the way, it is going to be -2. 3/4 of the way, it is going to be +2. And there it is. There is our one period of the graph. One period of the graph. And you only need to graph 3 points. But the only thing left to do over here is, it is asking us to graph this from -pi all the way to 3 pi. Well, then that means I need to graph one more period of 2 pi. Well, in order to graph that for a period of 2 pi, well, this is going to be 3 pi, right? So halfway between pi and 3 pi is going to be 2 pi. So pi, 3 pi over 2, 2 pi. So like 2 pi. And then I can say this is 3 pi. And then I can finish this right here, right here, right here. And there is a graph that shows tangent of x over 2 between -pi and 3 pi. All right, let's move on to the next one. So what do we got here? So graph two periods of y equals tangent of x plus pi over 4. So it looks like we got a phase shift happening in this case. So here we go. Let's get this going. So period, well, the period looks like it's not changing. So period is just pi over 1, which is just pi. So next thing comes my asymptotes. So vertical asymptotes. Well, if I kind of like think about it this way, right? If I think about this a little bit logically, I should be able to figure out where the vertical asymptotes should be without having to kind of like calculate it. Well, if I know this is pi over 4, right? If I know this is just being shifted by pi over 4, so that means if I have a point, like my default point is always 0, 0, right? That 0, 0 is being shifted over by pi over 2 or pi over 4. That means if I just kind of like label these increments by pi over 4. So this is pi over 2, 3 pi over 4, pi, and then I can kind of do the same thing over here, negative pi over 4, negative pi over 2, negative 3 pi over 2, negative pi. I should kind of be able to figure out where things are going to go. So like I know 0, 0, if the angle is 0, is being shifted over, positive pi over 4 is going to go to the left. So that means there's going to be a point right over here. There's going to be a point right over here. That's the new x-intercept that got shifted over. And again, like, what are you talking about? Well, take a look. Here is 0, 0. If I'm moving this point pi over 4, it's going to end up right over there, right? So that's kind of what we're doing. Well, if I have that, and there is no horizontal shift happening, right? Because this is just 1. There is no horizontal shift happening. Okay, so that means, and this is 1. So that means I'm not stretching it vertically. That means my 3/4 of the way and half or 1/4 of the way is still going to be -1 and 1, right? So that means there's our 1, there's our -1. So that means my vertical asymptotes are actually going to be sitting on pi over 4 and -3 pi over 4. Whoops, that should be a 4. 3 pi over 4. And there's the graph. There is our graph for it. And again, if that was like, wait, that was too much like thinking, mental math thinking happening over here, you don't have to, you can easily figure out all this stuff, just mathematically. So again, just to kind of show you how we would do that, well, this would be negative pi over 2. This is x plus pi over 4, pi over 2. Subtract pi over 4 from both sides, which will give me x by itself. So negative pi over 4 minus pi over 2. Well, I have to get a common denominator by multiplying 2. So that's negative pi minus 2 pi over 4. And you can clearly see this is negative 3 pi over 4 x. And this is pi over 2 minus pi over 4. So multiply 2, 2. That's going to be 2 pi minus pi over 4. Well, that's just pi over 4 for the vertical asymptotes, which is exactly where we graphed them. And then it's asking us to graph 2 periods, right? 2 periods. And if a period is pi, if the period is still pi, so a period is still pi, whoops, period is, so if this was a period of pi, I need one more period of pi, right? So that means I need to add one more tiny increment over here, which is going to be, because this is pi over here is pi, 4 pi over 4, this will be 5 pi over 4. Asymptote is going to go right there, halfway. And we're done. There you go. We've shown 2 periods of that function. 3 points. All you really need is 3 points. Min, max, middle. Right? So the next thing is cotangent. Cotangent. All right, so for cotangent, again, we're going to kind of do the same thing. I'm going to fill this chart in. And again, I'm going to focus in on these key angles. So again, like if I go to 0, well, 0 degrees is, remember, cotangent is x over y, which is cosine over sine. Well, if I do a 0 degree is going to be 1 over 0. Well, that's undefined. Oh, look at that. Something different is already happening. So pi over 6, if I do this in some decimal, I don't want to deal with it. Let's go with pi over 4. Well, pi over 4, again, is just going to be 1. And then pi over 3, I don't feel like dealing with it. That's randomness. I don't need to worry about. That's decimals. Let's go to just pi over 2. Again, pi over 2 really doesn't fall in. Let me actually, you know what? I don't even write. Let me get rid of this. So pi over 2 is going to be x over y, which is 0. So look at, we got this, we got this, we got this. So let's keep this going. So over here, 2 pi over 3, not really interested. 3 pi over 4, negative 1. 5 pi over 6, not interested. Pi I am interested in because that is going to be negative 1 over 0, which is undefined. Hopefully you're kind of like picking up on this pattern. So like if you go back to tangent, what are we noticing? Anywhere tangent was 0, now it's undefined. Anywhere it was undefined, it is actually 0. And it kind of makes sense, right? Because we're flip-flopping the positions of 0 and 1. Right, so let's go over here. So then over here is the only thing I'm really interested in, 5 pi over 4, which is going to be 2 negatives being divided, so that's positive 1. 3 pi over 2 was before undefined, but now it is going to be 0 over negative 1, which is just 0. Right, so over here I'm really interested in 7 pi over 4, which is going to be negative 1. 2 pi is going to be undefined, right? So we got our draft here to kind of like go ahead and graph this. So let's do this. So let's put in our asymptotes. So we see 0 actually has an asymptote. And then I also see there is an asymptote at pi, 2 pi. And I'm actually going to kind of like replicate that over here. Okay, so let's graph. So next one is pi over 4 is, pi over 4 is 1. Pi over 4 is 1. So let's go here, 1. Pi over 2 is 0. And then 3 pi over 4 is negative 1. So again, gives us a pretty good picture of what this cotangent graph looks like. There it is. So it's kind of like flipped. It definitely doesn't start at 0, 0. It's kind of like flipped almost from tangent, right? So rest, I know like if this is cotangent, there we go, there we go, there we go, boom. Like it's curved. So it's not like a straight line is going to come through. It's like a curve, then it approaches the asymptotes. This, this, this. And again, hopefully you're picking up something over here about the 3 points, which we're going to write down in one quick second over here. You finish this. Okay, here we go. So now, like we did before, let's write down some characteristics. Y is equal to cotangent of x. Cotangent of x. So what do we see over here? So we see period is still pi. So period is still pi. It repeats every pi period. So period is pi. Range is still negative infinity to infinity. Domain. Okay, something is happening with the domain, right? Clearly there's asymptotes. So all real numbers except multiples. What do I see over here? 0. I see pi. I see 2 pi. negative pi, negative 2 pi. It's going to be the negative 3, negative 4, so on, positive 3, positive. So multiples of pi. Multiples of pi. So like the 1, the 2, the 3. Right? So here we go. X-intercept. X-intercept right here. Halfway. Halfway. Halfway between vertical asymptotes. Right? Then we got our y coordinates. 1/4 and 3/4 is, now it's flipped. Just be careful. This one is flipped to 1 and negative 1 respectively. 1 and negative 1 respectively. So there we go. Those are the three things we're going to use to basically graph cotangents. All right, so now we have the graph of cotangent. Let's go ahead and put one in here. 3 cotangent of 2x. 3 cotangent of 2x. All right, so same thing we did before. We're going to find the period. And period is just going to be pi divided by 2, which is just pi over 2. So it's clearly shrinking. It is clearly shrinking. All right, because it's shrinking, so why don't we just do our scale? So what scale should I use to kind of figure out what this is going to be? Well, this is, remember, scale was just period divided by 4, which is the same thing as multiply by 4, so 1/8. So eighth, we're going to use pretty smally a word, small increments. All right, so 1 pi over 8, 2 pi over 8 is pi over 4, 3 pi over 8, and then we have 4 pi over 8, which is pi over 2. So there it is. And now let's do this. So our asymptotes, remember, are always, there is no shift happening, right? So this is just going to be, there's going to be an asymptote right over here. There's going to be an asymptote right over here. Halfway. Fourth. 3/4 of the way. And then there it is. There is your graph for this. And let's say I just had 2 periods, right? So I can kind of like take the easy way out. Why don't I just graph something right over here to call it 2 periods? Oops. Half this. Just remember 1/4 is always 1. 3/4 is always negative 1. No more, no less. All right, so the next in line for the other ones are cosecant and secant. So let's see what we got for that. So cosecant. Well, cosecant, if you remember, it is just 1 over sine of x. Okay, so let's do this. So let's see what we come up with. Angles and filling in our table just to kind of visualize what we need. So here we go. So cosecant. Cosecant is 1 over sine. So let me write down these angles. So 0, pi over 6, pi over 3, pi over 2. Let's ignore this quadrant thing, because obviously, because pi over 2 does not fall in a quadrant. 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi 3, 1 pi 6, and then 2 pi. Okay, here we go. Let's fill this in. All right, well, this is just saying 1 over 0 because 1 over sine of x, right? So sine is 0. So this is actually undefined. Oh, look at that. We are still dealing with some vertical asymptotes, huh? Okay. So clearly, anytime I'm going to have sine, whenever sine is 0, it's going to be undefined. So let me just kind of like take that shortcut out. Like it's clearly going to be 0 over here. So this is undefined. And then it's also 0 over here. So this is undefined. This is undefined. So I kind of like have our graph of sine already done. So we'll kind of take a look. We'll actually come back to that graph in a second. Let's kind of keep filling in our chart over here. So pi over 6. Well, pi over 6, this is 1 over 1/2, which is the same thing as multiplying it by 2. So this is going to be 2. So I know that anything to do with denominator of 6 is going to be 2. So this is going to be 2. This is going to be negative 2. And then this is going to be negative 2. Okay. Pi over 3, well, that's 1 over root 3 over 2. I'm not interested in that. That's some number. I don't care. I don't care about decimals. Right? Pi over 2. Pi over 2, this is just 1 over 1, which is 1. So that means 3 pi over 2 is going to be negative 1. All right. So now we have our numbers to work with. So we got this, we got this, we got this. And then we got this. All right, so now let's bring in the graph of sine, and let's take a look at these table values and see what we get. So let's draw in our undefined. So it's this, this, and this. I see 3 asymptotes in one period. So there is an asymptote right over here. There is an asymptote right over here. And here. Done. So pi over 2 is 1. Pi over 2 is 1. So let's graph this over here. Pi over 2 is 1, okay? Which is right over here. Pi over 2 is 1. Oh, wait, what? What is this? What's happening over here? Pi over 6 was 2. 5 pi over 6 was 2. Well, if this is an asymptote, that means we're going to approach it. So we're going to create this graph, and then we're going to do this. So it's this U-shaped looking thing. What is going on? So let's take a look down here. At 3 pi over 2, it was at negative 1. And then 11 pi over 6 is at negative 2. Negative 2. What? So interesting. Now, why does this make sense? Well, what do you see over here? Well, clearly, I'm starting to see some stuff happen. I'm starting to see that at any of the x-intercepts for the sine graph, there's an asymptote. That kind of makes sense, right? Because sine is 0 and cosine is 1 over 0. That's clearly cosecant cannot exist at those x-intercepts. So that is why those vertical asymptotes are there. And then we're starting to see that cosecant is opening up and down based on the highest. So remember, this was the max of sine. This right here was the minimum of sine. So you can see that it's opening up where there's a max of sine, and it's opening down when there's a minimum of sine. And I can kind of like, if I wanted to finish this graph, I can easily do this because I know there's an asymptote right here, over here. And then, like, I'm not even going to worry about this negative 2 and 2. All you need to know is where there is a max and a min, and then you're done. So really, in order to graph a cosecant, you really need to know what a sine graph looks like for that. And then whenever you see the max and min, boom, graph it opening up and down, and put the asymptotes wherever you see the x-intercepts for your sine graph. So again, with that, let's just, like we have always done, let's write down some characteristics. So characteristics of y is equal to cosecant of x. So period. In this case, the period is still 2 pi. Even though those asymptotes are there, the period is still 2 pi because remember, all of this is coming from the graph of sine of x. So the period is still 2 pi. Don't confuse it with the tangent and the cotangent. With the vertical asymptotes, this is still going to be 2 pi. Still going to be 2 pi. All right, so domain is going to be all real numbers except multiples of pi. So like the 1 pi, the 2 pi, the 3 pi, the -1, the -2, and so on and so on and so on. Our range is going to be, actually we see that it is going to go to -infinity, then it comes to -1, which is part of it, union 1 to infinity. Vertical asymptotes, so again, multiples of pi. So those are some of the key characteristics. And again, obviously, knowing these points, the mins and the max, how it opens up and down from it, also the characteristics of the graph. But as long as you know what the sine graph looks like, cosecant graph is easy because you really need to focus in on the max and the min points and the asymptotes. All right, so let's take a look at, before we do some practice problems, let's just take a look at secant of x. Secant of x. All right, so secant of x, remember, is just 1 over cosine of x. So let's fill this in. So again, I am interested in some good, easy numbers to work with, right? So let's go with 0. Well, 0 is just 1 over 1, which is just 1. Okay, so that means at least 2 pi is going to be 1 for me because the value of cosine of 2 pi is also 1. Right? So the next in line is pi over 6. Pi over 6 is square root of 3 over 2. I'm not interested in anything to do with that. Too much work. Pi over 3. Well, pi over 3 is 1 over 1/2, which is going to be 2. So anything to do with that, anything to do with the denominator 3, I'm definitely interested in. So like 2 pi over 3 is -2. That means pi is 1. 5 pi over 6, not interested. It's some number, don't care. So 7 pi over 6, don't care. 4 pi over 3 is going to be -2. 3 pi over 2, well, value over here is 1 over 0. Well, that is undefined. So that means pi over 2 is undefined. So you got 5 pi over 3, which is going to be negative, no, not -2, this is going to be +2, sorry, +2. And then 11 pi over 6, don't care, it's some number. All right, so let's see what's happening over here. So undefined at pi over 2, and 3 pi over 2. Let's see. Here's our graph of sine. What do we notice? Undefined at pi over 2. Look at that. Another x-intercept, right? It makes sense that if cosine is 0, secant can exist. 3 pi over 2, x-intercept. Negative pi over 2. 3 pi over 2. And if you're kind of like observing this thing, wait a second, this is actually the same pattern as sine, and it really, really is. It really is the same pattern as sine. At 0, it's at 1, and then at pi over 3, 2, 2, boom. There you go. There's your graph. There's the graph down here, down here, down here. So that's all there is to it for secant. Just know what the graph of cosine looks like, graph cosine, and then put everything else for secant right there for the max and min. It's always going to be for the max and min. All right. So with that, let's again kind of like just write down some of the key things over here. Period. Still 2 pi. Domain. Again, this is going to be all real numbers except odd multiples of pi over 2. Take a look. You can clearly see negative pi over 2, negative 3 pi over 2, positive 3 pi over 2, positive pi over 2, that 1, the 3, the 5, so on, and so on, and so on. Range. Same thing. Include negative 1, 1, 2, infinity. So where do I put the vertical asymptotes? At odd multiples of pi over 2. All right, let's do a couple problems. So graph two periods. Graph two periods of two cosecant of 2x. Step 1. And actually, whoops, I don't want to erase the whole thing. Don't want to erase the whole thing. Let's actually make some room for us. I'm not going to need this side. All right, so let's go. Step 1. Graph y is equal to 2 sine of 2x. Always just graph the sine function first. It just makes our life that much more easier. Right? So to graph that, we know the period is going to be 2 pi over 2, which is pi. So scale is going to be just pi divided by 4. So pi over 4, 2, 3 pi over 4, pi. Right? So at least that will be the one period of it. And then since I'm doing two periods, let me keep this rolling. So this is going to be 5 pi over 4, 6 pi, 3 pi over 2, 7 pi over 4, and then there's our 2 pi. So those are two periods. And this is cosecant. So sine is going to be, so there is an amplitude, right? There is this amplitude over here sitting at 2. So let's see here. Let's do this 1, 2, oops. 1, 2, 3, 4. 1, 2, 3, 4. So amplitude is at 2. So let's go here. So period is pi, 2 pi. And then we're going to bring in asymptotes, other asymptotes over here in one more second. So let's finish sine first. So sine starts at 0, 0. Halfway is another intercept, right? Halfway is another intercept. Quarter of the way, max. 3/4 of the way, min. And then it comes back right here. So we officially have one period of this. So we are going to do the same exact thing to repeat two periods of this. Dot, 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 dot. Okay. And we can bring in other asymptotes. So you always want to finish all your asymptotes. Come on. Let's go, pen. And then wrap it up. And there it is. Oops. Wow, the pen is just lagging. There it is. This orange looking thing is the graph that we are interested in for our secant. Sorry, cosecant. There it is. Boom, done. We have shown two periods. All right, one last example. Let's do secant. So let's graph cosine first. So this is going to be step 1 again, is graph cosine of this. So this is going to be y is equal to 2 cosine x plus pi over 2. So period is 2 pi. Phase shift is pi over 5 pi over 2 pi over 2, positive pi over 2, And then let's see here. Do I need to write anything else? My midline isn't changing and the other stuff isn't changing. Okay, good. So, oh, wait, sorry, amplitude. Amplitude is 2. Cool. Okay. So let's do this. Pi 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi, negative pi over 2, negative pi, 2, negative 2 pi. Okay, here we go. 1, 2, 3, 4, 1, 2, 3, 4. All right, so we're graphing sine. So let's do sine, and it is being shifted over by pi over 2. So that means my amplitude is 2. Starting point is right over here. All right, then comes 0. This is going to go right over here. It's going to go down to right over here, 3 pi over this. Then it's going to come to pi. Something seems a little bit off. What did I mess up on? I got to figure out what I messed up on right now. What did I just mess up on? What did I just actually here? Let's see here. What did I mess up on? Let's see. So you can always kind of check. So like my points mentally in my head for some reason are not adding up. Okay, here we go. Anyway, 0 do x plus pi over 2, 2 pi. So negative pi over 2 x. And then this is going to be 2 pi minus pi over 2, negative pi over 2 x, 4, 3 pi over 2. So, okay, there we go. There's should be fixable now. So my max is going to be at negative pi over 2 at the amplitude of 2, at 3 pi over 2, which is right over here. Okay. And halfway in between is this right over here. So that means 3 pi over 2. Let me get rid of these things here. 3 pi over 2. Okay. This is brain freeze happening right over here. Shift this right over there. And then I know I need to end at 3 pi over 2. Okay, so the halfway between would this be? Then let's see. Quarter of the way is this 2 right here, 2 right here. There we go. There we go. I was like, what in the world is going on? What in the world is going on? Okay, finally. Sorry about that hiccup. And let's graph this thing up. So this is right here. Right here. Okay, so asymptotes at the x-intercepts. Right over here is our asymptote. Right over here is the asymptote. And then we can finish to make this graph right here. And then right here. There it is. There we go. This is our graph of 2 cosecant of x plus pi over 2. And we're done.